Now is the good time to actually discuss one of the most crucial, most topic also, and in general also one of the most key ingredient of a software development life cycle, which is solid principles. So solid principles are basically existing to promote uh, code maintainability, code extensibility, understanding, and making the overall application or the functionality scalable. Right. The solid principle stands for single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion. We'll deep dive into it bit by bit. So single responsibility basically promotes your single class should be responsible in doing single job. It is not. It should not happen that your single class is doing multiple jobs. So a basic example for this would be uh, like let's say you are generating an invoice and your class invoice is also generating the Excel report. Your class invoice is also generating, also saving certain logs in the DB, right? So you create one class invoice. This should only be responsible in calculating total, for instance. Then you should create one more class repository. This should be responsible in doing the saving operation. And then one more class can be created, email service, and this should be responsible in actually sending the invoice to the end user, right? This basic example should be sufficient for the interviewer. Now we move ahead to the open close. The open close principle promotes that your whatever code we have or the classes we have should be open for extension but closed for modification. In order to demo this, we will also understand one key important concept in Python called as abstract based classes. So in order to create an abstract based class, we need to import this from ABC. Import ABC. ABC is basically abstract based classes, and inside ABC only you get abstract method. We can create a class called as shape. We create an abstract method here, and this we can create a definition or a basically function of this abstract base class uh, that will have self. Now we can have a class called as circle, and this will be inherited from shape. Let's consider this circle having accepting some radius. So this will be self dot radius equal to radius, and this function this class now overrides the method from the abstract base class shape, and this will again have self. Now this will return 3.14 into self dot radius into 2. Okay, we can again create one more class square. This will again have in it done the method self comma. This time this will have side, self dot side equal to side. We will use area same as before, and it will have self. Here we simply return self dot side into 2. Now we can create a shapes list where we pass circle as 5 and we pass square as 4. fluorescent shapes is dot area. Now we move ahead and execute this. Yeah. So this is how the thing will get executed. So this is a good demo code that you can show as the open close principle. Now we move ahead to Liskov substitution. Liskov substitution basically says that your child class shouldn't change or alter the behavior of the parent class. In order to demo this, we can create a class called as bird, and this by default does the pass operation. Now we can have a flying bird, which will have a property of fly. Let's simply call this as flying. We can have one more class called as penguin, which is inheriting from bird. Instead of fly, this will have swim property. Here we can write swimming, right? But we move ahead to interface segregation. Interface segregation promotes that your client shouldn't be enforced in implementing methods that they do not use. A simple demo for this could be you implement a class called as iter, and this again becomes an abstract base class. So this will be inherited from abc, and abstract method will be inherited. Inside this we have 8. We can pass this, and this will have abstract method. This will be decorated as abstract method. Similarly, we can have classes flyer, and we declare this again as abstract method, and this will have self pass, right? Now we can declare one animal, dog. This inherits from eater, and this has some eating property, and here we can read print dog eating. Likewise, we can have one more class as parrot. This will inherit from both eater as well as flyer. So here we can write parrot eating, and we can write parrot flying. Okay, so this is a good demo code that can be implemented to support the claims of uh, interface segregation. Finally, we'll move ahead to dependency inversion. The dependency inversion talks about your higher level classes shouldn't be dependent upon the lower level modules. Uh, a good use case example of this would be some kind of database operation, uh, right? So I'll write the code for it. Again, we'll need the abc package. From abc import abc, an abstract method. We have a abstract class of the database. This has a save method, self comma data, and we pass this, and we decorate this with abstract method. Now we can have a class as mysql db, and this is inherited from database. This overrides the save method of the inherited class, and this will again have self comma data, and here we can write saving data in mysql. So similar to this class, we can have multiple classes belonging to multiple databases. We finally create a user service class, this gets initialized as db colon database. So basically, whenever we utilize the user service, we will be expected to pass the database, and this is how we avoid the uh, higher level modules being dependent on the lower level modules, right? And we declare a function called as save underscore user self comma user. Now we call self.db.save. So basically, this db is basically this, and this is inheriting from abstract base class, and this has the method of save. So from this we reach here, and we are able to call this, and we pass the user. Now let's call this user service, and we call mysqldb. Now we can call this service dot save underscore user shadabsk. So this is a good example that we can show as a dependency inversion. It just needs practice once or twice, and then you'll get a hang of it. There is one more important thing that we are doing at the class user service. There is abstraction layer which is already being achieved using abstract based classes. There is also a concept called as abstraction, encapsulation, that is being achieved from user service class. So user service class hides how the user is being saved. The outside world does not know whether we are saving to MySQL or a different other database, right? The only thing other part of the program know is that they call save underscore user, right? All the internal details stays inside the class. The service exposes only what is necessary, that is encapsulation. We kept the data and the related logic together and hide unnecessary details. This keeps the code clean, maintainable, and easy to change later without breaking anything outside. So through this, we also understood abstract-based classes. We also understood encapsulation, abstraction. Yeah, so that's about it for this session.